Hello students, we are back at Easy Chemistry. Today we will slightly talk about the bonding between two elements, and in order for me to talk about the bonding between the two elements, I would need to talk about the orbitals of any single atom. So as we know, every element is arranged in a periodic form in the periodic table. The arrangement is periodic. When I say that, I mean that after a given set of numbers, maybe 8, 12, 16, the property of the element recorded repeats itself. Such a kind of arrangement wherein the elements are arranged in definite proportion is termed as periodic table. So now coming to the periodic table. This is chemistry wherein any atom or any element is not left alone. In the entire system of chemistry, there is always either bonding or separation between two atoms or two electrons. So now the concern is how do the electrons form bonds with each other. So my dear students, what happens is an element, let's say carbon, has 6 electrons. 6 electrons are arranged in two layers. The innermost layer has 2 electrons and the outermost has 4 electrons. So if this outermost 4 electrons get donated to, for example, this is a hypothetical example I am taking. If the outermost 4 electrons is donated to, let's say, fluorine, then carbon will be 4 positive because 4 electrons will have been gone, and in that situation carbon nuclear strength would be limited. But since carbon had already donated those 4 electrons, it cannot do anything. So the carbon molecule would get destroyed and would be vanished or deacted. So now being carbon, since the nuclear strength is less, what I mean by nuclear strength is the strength with which the center of the atom keeps the outermost orbital intact is less. Now children, to give you a good live example so that you understand, it is said that if there is no gravitational pull in the sun, then one Earth day would equal to 60 hours. Because the Earth would take longer time to rotate because there will be no control or no attachment with the sun. So you understand what I'm trying to talk about. If the sun here is the nucleus of the atom, and if there is no attraction or the nucleus doesn't keep the outermost electrons in control, then in that situation the electrons would go haywire and the bonding would be always ionic. Because the electrons are mobile or volatile in nature, so because of their mobility it would be easy for them to move around. On the other hand, if I say that we can instead of donating we can share the 4 carbon electrons with each other, then what will happen is both the carbon atoms will be intact and the nucleus will have enough strength to keep the shape of both the carbon atoms intact. However, there are some elements like sodium, potassium, strontium, which easily donate electrons and form ionic bonds. When I say ionic bonds, what I mean by that is sodium is one such element which is always in a hurry to donate its electron. So that is why the Na plus ion of sodium is very unstable and highly reactive. So it's easy for sodium to get hung up with a chlorine atom. That is why you would see that sodium chloride is a very common compound in the ocean area. So now the sodium, that is because the nucleus of sodium has a stronger force with which it controls the outermost electron, and sodium for itself has one valence electron, which means like carbon had 4 valence electrons or tetravalency. Carbon showed tetravalency, so it had to share. However, sodium showed monovalency, so it can donate. Now this donation can be governed by type of bond. When I say type of bond, I mean in an element the angle at which the electrons are present in the outermost orbital or the valence electrons or the valence shell electron theory, that angle depends based on the attraction force between nucleus and the outermost orbital. So if that outermost orbital is at a smaller angle or a acute angle, then the force is higher. This kind of a force is termed as pi force or pi bonding force. If the electrons at a obtuse angle, then the force is lower. It is then termed as obtuse angle force or sigma bond. Now this pi and sigma bonding of different elements have a great repercussion or a great effect when these kind of elements go on and form isotopes or isomers. Why? Because the pi bonding of elements leads to the formation of a cis kind of isotope, and sigma bond leads to the formation of a trans isotope. Now this topic will be dealt when we are meeting the next time, isotopes and enthalpy, and we shall see if you people need some notes. We shall definitely discuss that and provide the same as well. Till then, take care. Thank you.